Okay, let's take a look at case study 8, which is the CG Space Capsule project. As you can see, this is the final render, okay, one of the snapshots. So the project aims to demonstrate a series of potential professional workflows that involves in visual effects productions. I really hope this demonstration can help your future studies. The main production stage in this project has been divided into 3 different stages, as you can see here in pre-production, production, and visual effects production. Pre-production includes determining shooting methods, on-set data requirements, for instance. The second stage is to film live-action footage and capture on-set data. The visual effects production involves editorial and also preparation for 2D assets, 3D camera tracking and match moving, creating 3D space capsule, then go through texturing, rigging animation, lighting, final rendering tests, then eventually render all the AOV parts out for final compositing and final delivery. So it's always good to understand the shot, what is happening in the shot, for instance, the story and cameras and what kind of elements we have, movements, lighting conditions, and so on and so forth. In this shot, basically it's telling a character is trying to escape from the machine system. Then eventually he met a space capsule underneath the skylight of a tunnel. So with the essential story understood, let's take a look at what kind of shooting method will be used. Because the guy is trying to escape something, the shot has those intense, insecure feelings. So to create that sort of sense, a handheld filming method is used in this shot. The filming was taking place inside a tunnel. This is the camera we used. It's a full-frame camera, and also we used a full-frame lens. And the frame per second is 24. Footage color space, and we used S-Log3, S-Gamma 3, which is 10-bit. The camera focal length is 20mm. So before filming, we actually went to the location. This is the entrance of the tunnel. The reason this reference image is taken is because if you work with a team, everyone in the team should understand what is happening on set, including the structures, then camera positions, all the activities, and also lighting environment. In this case, we purposely capture the sun position, and also through the shadows cast by the trees, we can even approximately calculate the temperature of the day. So in production, scanning the tunnel is one of the key activities on set. In this project, we used Insta360X to capture 2 elements. One is to scan the tunnel, one is to capture HDRIs. So this is the reference video we captured inside the tunnel to provide all the necessary information to artists who work in this project to understand what is going on here. So after scanning the tunnel, the data is imported into Maya for rebuilding the tunnel based on the real-world scales and references. Now we can see this is the scanned data which has been brought into Maya. With this initial scanned data, the model has been rescaled to match the real-world size of the tunnel. So based on the scanned data, we rebuilt the scanned tunnel. So this is the tunnel we rebuilt in Maya and matched with the original scanned tunnel. Also, we use the same camera to capture on-set HDRIs. Basically, the camera has set different exposures, use 0 stop as a baseline, and go plus and minus several stops, then eventually capture images. Then after that, we combine all those images which contain multiple exposures. Then eventually we can create a 360 HDR image for lighting the CG in this scene. Now we can see this is the created 360 HDR image in the tunnel. This is the live action footage we filmed in the tunnel. Because the color space is S-Log3 and it's 10-bit, that's why it's looking flat on computer monitors. This page displays 4 different color gamuts within the color information which can be perceived in human vision. The one on the left is ACES 2065-1, which is the widest color gamut, covers pretty much the entire color information we can see in the real world. It's under the linear sRGB color space. This is an exchange format for sharing high-end footage between studios. The second one is ACES CG, which is also linear color space. It's used as a standard color space in the visual effects industry. The third one is sRGB and Rec 709 color gamut within the triangle shape. This is the smallest color gamut, and this color gamut is widely used in regular computer displays and digital images, especially for online. The last one is DCI P3 color gamut, which is slightly bigger than sRGB and Rec 709, and is specifically used for cinema projectors. So the reason we need to understand these 4 different color gamuts, especially when you work in computer-generated images, you want to work with more color information. Then after the work is finished, the final output of the images can be delivered for different devices, for instance, for computer use, for TV sets, and for cinemas. Under the ACES CG color gamut, we have listed 4 different elements which should be used in different color spaces, for instance, live action footage and rendered AOV passes and utility passes, and also HDRIs. Now let's take a look at how these different color gamuts are applied in this project. We can say this is the original live action footage we filmed on set, and the color space is S-Log3, S-Gamma3. During the production, we need to convert this color space to ACES 2065-1. If we do a comparison between the color converted live action footage and the captured HDRI, the live action footage is looking warm and saturated. We can clearly see a bluish tint embedded in the captured HDRI. So to use this HDRI as a light source for lighting the CG characters eventually will be integrated with a live action footage like this. Obviously, the color lit by the HDRI will not match with this lighting environment. This requires a color conversion, so this process is called color neutralization. As we can see here from this diagram, we have different elements. The live action footage is ACES 2065-1, which is assumed to be delivered by external studios. The HDRI is an open EXR format which has linear color space, and also we have different elements and textures under different color spaces. So the solution is to convert all the different color spaces into ACES CG. So for visual effects production, we work in ACES CG color space, as we can see here. At this stage, after neutralizing these images, we can say the colors are looking really similar. If we use a light source embedded in this image to light the CG character, which will be eventually integrated into this live action plate, then the final result will be looking really convincing. This is the script for neutralizing plates. As you can see here, this is the HDRI and this is a live action plate. Alright, let's take a look at these plates. So this is the original HDRI combined by images we filmed on set with different exposures in the linear sRGB color space, and the format is EXR. If we take a look at the RGB numbers in the highlights, they are above than 1. I used an exposure to bring up a couple of stops, then eventually we can properly see the image. Okay, now if we do a comparison between this HDRI and also the live action footage, which is currently in the ACES 2065-1, through the comparison we can say the colors are quite different. This one is cool and a sort of bluish tone, but this one is looking warm and saturated. With the initial image of the HDRI created, if we use the light sources in the tunnel to light the CG character, eventually integrate the character into the live action footage, the colors will not be matched. So to go through the neutralization, then eventually we turned these two images into something like this. Now if we take a look at both images, they are looking really similar after neutralization, and also they are under ACCG color space. So to go through the neutralization process, I used an external nuke gizmo called Color Target, which is created by this excellent artist. Then eventually use this gizmo to generate a color matrix under the sRGB color space. Then after that, if we do a comparison between before and after, we can clearly see the dramatic color change. Then after that, we convert the sRGB to ACCG. You can clearly see if we do a comparison, the color is changed. Okay, before it was really warm and saturated, now it's more realistic. Then after that, I added a roto paint node just to paint out, the color chart and also the camera tripod. After a careful comparison between these two results, then I'm seeing this area here. To me, this one is slightly darker than this image. That's why I increase the exposure for this one from here to here. Now, if we do a comparison between these two images, they are looking pretty similar now. This is the script for removing lens distortion from the live action plate. As we introduced in previous chapters, we filmed a lens grade which used exactly the same camera, lens, focal length, and frame per second, and all the settings used for the live action footage here. Eventually, we remove the lens distortion from this plate, as you can see here, before and after. Then we cloned this node and use the data to remove the lens distortion from this shot, before and after. After that, we can say that's the overscan size around the image. After removing lens distortion, it is time for 3D camera tracking. In this project, we use an external professional 3D camera tracking application called Sentize, and the total of error after 3D camera tracking is around 0.6, which is not too bad. We walk through the tunnel, then after that, the camera suddenly tilts up. The turning point is here, which causes errors during 3D camera tracking. And also we have noticed this is a quite long visual effects shot, around 500 frames. Usually each visual effects shot is divided into something like 300 frames or 250. If this long shot was divided into two separate shots, the tracking error should be much lower than 0.6. So it's always good to know how a visual effects shot can be divided into separate shots professionally to avoid any potential tracking errors. The 3D camera tracking is done quite accurately. This is why the reconstructed tunnel matches really nicely with the live action plate. Now you can see this is the 3D tunnel we built up, also matched with the real world scale. The created HDRI map is projected onto the tunnel through this camera. If I quickly switch to the camera itself, we can see the camera is facing the skylight and use a spherical reproject the HDRI onto the entire tunnel. And also we imported the tracked camera, as you can see here. Then eventually, with this environment built up, we can place the 3D space capsule inside this environment for further operations. For instance, you can test the textures, lighting, and also animation. Now I'm going to show you how to get the HDRI projected on the 3D model of the tunnel. As you can see here, the tunnel has got no materials assigned. If I go to the hypershade, I'm going to use a surface shader here. Select the tunnel. Right-click assign material to viewport selection. Then after that, I need to give a proper name. Then after that, click the Alt Color check icon here. In this new window, you will see a file icon. Then right click and hold. Then create as projection. Click it. Then after that, we can rename it projection texture, let's say. Then click the image slot and click this connection here. Then image name, click the folder, then navigate to the case study project files folder, then project assets folder, then HDRI open EXR folder. Then what you want to use is the Eternal HDRI ACCG EXR file. Click it, open it. Then after that, under the color space, default is going to be set to raw. You want to change to ACCG. If we go back to the projection camera, you can say by default the project type is set to planar. However, you want to switch to spherical. Then after that, if I press number 6, and you can say this is the projection. Okay, now we can say the HDRI is projected onto the tunnel, and also we have these light sources properly located inside the tunnel, so we can put the CG character inside this environment to light it. If we use the traditional lighting, which is a sky dome around this CG character, and when the character is interacting with the tunnel, this area should receive shadows cast by the edge here. However, the sky dome cannot do that. This is why I decided to use a separate camera and project the HDRI map onto the tunnel. Alright, now let's take a look at the creation of the space capsule. This is more like a blueprint. We can say different views, front, side, and top views. Then based on this design, we created a 3D model, and also we unwrapped the UVs. Then a checkerboard texture is applied to this CG character. Then eventually the 3D model has been brought into Substance Painter for creating 3D textures. This is the final created texture which contains different passes underneath. The current color space is ACES sRGB. So for color passes, we must convert them into ACCG. This is Substance Painter. You can clearly say, all the materials and also textures are applied already. We can say base color and height, which is the displacement map, roughness, metallic, normal for relighting, mask, ID paths, ambient occlusion, and also some other passes down here, for instance, position paths, opacity, etc., etc. And also it's worth noting here, all those passes are created under ACES sRGB. For the color paths, which is base color, this map should be converted to ACCG from the list here. For instance, height, roughness, metallic, and normal, they are utility passes. All these utility passes should be kept as raw. This is something you need to keep in mind when you work in Maya or some other 3D applications and trying to connect all the passes, apply them to your 3D models. The rendered textures we created in Substance Painter are saved under the case study project file, and if you go to 804 Space Capsule Final Maya Scene Source Images folder, then all the textures are saved under this folder, as you can see here. We have 8K files for the body area, and for both caps, they are rendered at 4K images. All the base color images are ACCG. So let's take a look how these files are connected in Maya. Open Hypershade, As you can see here, I've got two materials built up. One is for the body area, one is for the cap. So this is the network built up for the body area. I'm going to use these two nodes as examples. First of all, double click the node and load the properties here. Then you need to locate to the folder where the texture files are saved. As you can see, this is a normal path and it's 8K and also is utility path. So load it, then under the color space, use the default raw color space, okay, for utility passes. However, if we click this node, we can say this is base color texture 8K and it's converted to ACCG already. So under the color space, we need to use ACCG. So the same principles can be applied to all the Maya files here. And also this one. This is displacement map, which is connected later separately, as you can see here. And this is connected to the height, 8K, and also is utility, then set to raw. The same thing applies to both caps. Then for color passes, we use ACCG, but for utilities, we use raw, as you can see here. And this is ACCG because it's a color pass. During look development, I also tested how the textures work under different environments. This is another test with a different environment and also another angle. Eventually, all the AOV passes of the CG capsule are rendered out from Arnold in Maya for final composting. This is the nuke script for case study 8. We have different parts. First of all, preparation and also external operations and also composting. In this section here, we have demonstrated preparation sections separately. For instance, neutralizing colors for the HDRI and live action plate, and remove lens distortion. And this section is to calculate the undistorted overscan sized plate. For instance, that's the original. Then remove lens distortion. Then after that, calculate the overscan size. Then we can say the formula is used here. External operations are also briefly demonstrated, for instance, 3D camera tracking in Sentize, and also 3D match moving, and lighting, and so on. Inside this EXR file, which is ACCG color space, if we take a look at them one by one, this is matte we rendered, and depth data, normal for lighting, normal for edges, position paths, and skylight reflection here, and diffuse with light, and motion vector. The motion vector can be seen under here, motion vector. Because the movement is different in every single frame, so the motion vector can be different as well. The specular and also albedo and Fresnel, and also AO passes, ambient occlusion pass, and also shock wave pass 14, 16. We start to say a 2D pass. Then eventually this pattern is used as a mat for creating the shock wave later. We started the comp from this area, and we can say that is the original live action footage. We changed the original color space ACES 2065-1 to ACCG, so we can do a comparison, especially in this area here. Before, after. Now let's take a look at the CG passes. The CG character is rendered out as a combined image. However, we have all the different passes included inside this path. For instance, if we take a look at the RGBA, from the drop-down list, we can say all the different passes are here. So we need to separate them. To do it, we use shuffle node. As you can see, I'm going to use the matte path as an example in the properties section of this shuffle node. Okay, it's shuffled from the original alpha to the red one. The reflection, specular, diffuse. After separating all the necessary passes, we start to recombine them. For instance, specular and diffuse paths with shadows, we plus them on top of each other. For the AOA paths, we multiply it to this result. If we do a comparison before and after, you can see some really soft shadows going on. Okay, before, after. Alright. Then after that is a grade node and grade some details on the character. If we switch to the alpha channel of this image, now you can see there is no alpha going on in the A channel until this point. Then after the grade node, we copied the matte of this CG character into the alpha channel of this result. Now the matte is copied into the alpha channel of this image. Now from this point we start to deal with pre-multiplied image. You want to be really careful for color grading, and if you apply the film grain, then everything needs to be unpre-multiplied, then do the operations, then pre-multiply it back again. Okay, because this is a pre-multiplied image. After the copy node, we have connected a vector blur. Because the CG character is dramatically moving in the scene, it will produce motion vectors. That is why we use motion blur to blur it a little bit based on the vector data embedded in here. Then after that, because this is a CG render, we don't have any film grain content. So during filming on set, I placed a little color checker inside the scene in order to capture the film grain as a reference. So as you can see, this image is also converted to ACCG. I analyze this middle gray here. Then after that, apply the analyzed film grain to the CG character. If we go back to the vector blur node, this result is a pre-multiplied image which has a matte. So before applying film grain and color grading, we need to unpre-multiply it. Then after that is, in this case, a regrain process. After the regrain operation is finished, we want to pre-multiply it again. Until the pre-mult node, we were dealing with the final overscan size that was used as a reference for rendering 3D elements in Maya. With a combination of these three nodes, we're going to return to the initial overscan size of the live action footage after the lens distortion is removed. So to do that, we used a transform node first, and to calculate the lower right overscan size, the value here is from this point to this point after the lens distortion is removed. So that value is calculated. How do I know that? If we go back to the original live action footage after lens distortion is removed, that's the value. The values here is from this point extended to this point after the lens distortion is removed. So we used the same value in the transform node X and Y slots here. Then after that, we cloned the reformat node. In the output format, we use the same aspect ratio of the original background plate, which is 3840 by 2160. Then if we combine these two nodes together, we restored the original size of the plate after lens distortion is removed. Then after that, it is time to apply the lens distortion, which was extracted from the live action footage before, after. After that, this result is going to be integrated into the background plate. Okay, this is a background plate. Then we use the merge over. Then after that, when we moved to certain areas, we generated this light and eventually then use a plus operation and put it on top of that. A slight halo is produced that looks more natural. So we turn the result from this to this. After the volume raise is added, we also produced 2 heat waves to add a bit more interesting features into the scene. This is the rain effect we created in Maya directly and rendered out as a matte. This path is used for creating the heat wave through a gizmo. We use a time offset, shifted the time a little bit to match with the action, then after that blur it a little bit. Apparently this is an all scan sized path and we need to return and match with the original live action plate after lens distortion is removed, as you can see here. By using these 3 nodes. After that, apply the original lens distortion to it. Then we can connect this effect through mask input of the first heat wave. With the same method, we also produce the second heat wave in some other frames. Then after that, we also add a lens flare at this frame, as you can see here, over a plus operation. This is one of the frames of the final composition. We can also click the link directly to see the final output, which is available on YouTube. After the composition is finished, it's about final delivery. We have 2 output scenarios in this project. In the diagram here, we have something called IDT, that means input device transform in terms of color spaces. It doesn't matter what kind of color spaces we have in all those assets. Then eventually, during visual effects production, we convert them into ACCG. For a final output, we need to consider something called ODT, Output Device Transform. For instance, sRGB will be used for computer monitors, and Rec 709 and Rec 2020, they are for TV sets, and also DCI-P3 is for cinema projection color space. The second scenario is more comprehensive. For instance, your client will deliver the footage directly converted from RAW to ACES 2065-1 or directly from RAW to ACES CG. After the composting shots are finished, we also provide 2 color spaces. One is the neutral grade version. Another result is the client lookup table applied. Then eventually we deliver those results back to the client after receiving the completed visual effects shots. In post-production houses, the visual effects shots and non-visual effects shots will be mixed together for further editing and color grading processes. Then after that is about digital intermediate. Before the final distribution, the color output device transform should be considered. For instance, sRGB for computer monitors, Rec 709 2020 for TV sets, and also many other media platforms and related lookup tables.